What we want to do in this video is figure out the volume of this rectangular prism here. So pause this video and see if you can do that on your own before we do this together. All right, now let's work through this together. And we're actually going to think about it in three different ways. And to help us do that in those three different ways, we'll visualize this volume in these three different ways. So the first way to visualize it is, let's just think about it as, if we think about it as cubic centimeters, 5 going up, 4 going across, or 4 wide, and then 3 deep. And so that's what all of these show. And in this first diagram, what we first can think about is how many cubes, how many orange cubes are in this first layer. Well, this first layer right over here is going to be 4 cubes in one dimension. Actually, let me scroll down a little bit. It's going to be 4 in this dimension right over here, and there's going to be 3 in this dimension. So if you think about how many cubes are there, that is 4 times 3 on just one base, or one layer. And then how many layers are there? Well, we can see that there are 1, 2, 3, 4, 5 of those layers. So then you can multiply that times 5. Or another way to think about it is, in that base layer there, if you did 4 times 3, you're going to have 12 of those cubes. And then you have to multiply 12 times 5. Which you might just know as being 60. Let me do that in the same color as 60. Or you could do repeated addition if you like. You could say, well, that's going to be equal to 12 plus 12 plus 12 plus 12 plus 12 plus 12, which also is equal to 60. And that's 60 of what? Well, each of these things is a cubic centimeter. So that is 60 cubic centimeters. Now we could approach it a different way. We could think about one of these, I guess you could say these vertical layers first. So this vertical layer in this example, it is 1, 2, 3, 4, 5 high. And then in each of those 5 rows, we can see it has 1, 2, 3, 4 cubes. So how many cubes are just in this orange part here, this orange layer? Well, it's 5 times 4, which is 20. And then how many of these layers are there? You could almost think of them as walls. Well, we could see that there's one, let me just do a different color. We could see that there are 1, 2, and 3 of them. So then you can multiply that times 3. Well, 5 times 4 is 60. Sorry, 5 times 4, my brain is cutting to the chase. 5 times 4 is 20. And then 20 times 3 is going to be 60. Once again, 60 cubic centimeters. And you can do that with repeated addition. 5 times 4 is 20. 20 plus 20 plus 20 is 60. Now you could imagine where this last way of thinking about it could go. We could just think about how many cubes are in this right wall. We can see that it is 1, 2, 3, 4, 5 high. So it is 5 high. And it is 1, 2, 3 deep. So in this last diagram, you have 5 times 3, which is the same thing as 15 cubes. And then how many of these walls do you have? Well, you could see you have 1, 2, 3, 4 of them. So times 4. And so what is that going to get you? Probably not a surprise. 5 times 3 is 15. 15 times 4, you might know that that is going to be 60 cubic centimeters. Or you could say that that's the same thing as 15 plus 15 plus 15 plus 15. 15 plus 15 is 30, plus 15 is 45, plus 15 is 60. It's 60 cubic centimeters. Why did I put cubic centimeters here? Well, that was what we were counting the entire time. Every one of these layers we're counting in terms of cubic centimeters. Each of these little cubes right over here is a cubic centimeter. Now you might be saying, what was the whole point of me doing this 3 times like this? Well, it's to just show you that you can think of volume as multiplying the area of one side times the last, or the area of one layer, or you could think about it, the area of the base. So in this first example, if you think of the base as something like this, or if you think about the area of this base right over here, so 3 times 4, which we did first, or 4 times 3, and then we multiplied that times the height. So base times height. That's what we did here. Or you could think of it the other way. You could think of it as, well, we could multiply, we could find the area of that side, and then multiply it times the other dimension. So 5 times 4 would be the area of that back side, and then you could multiply it times the 3, once again to get the 60. Or last but not least, in this last example, you could say, all right, let's find the area. I could say the area of this right side, right over here, which is going to be 5 times 3, and then multiply it times that fourth side. But in all the situations, I'm just multiplying the sides. I have 4 times 3 times 5, 5 times 4 times 3, 5 times 3 times 4. I use the parentheses to do some of that multiplication first, but when you're multiplying 3 numbers like this, it actually doesn't matter the order that you are multiplying them in. So you just have to think about the 3 sides here and multiply them in some order, and any way you do it, you're going to get 60 cubic centimeters.